Welcome to MRS Bulletin's Materials News Podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Sophia Chen. If you're in a building right now, take a look at the windows around you. In daytime, these windows let in more than 90% of light to brighten up the space and warm it up. That warming can be welcome when it's cold outside. But if it's summertime and you live in a hot area, that window is counteracting the effects of your building's cooling system, lowering its energy efficiency. So that's why researchers are developing a technology known as smart windows. These are windows that can change their transparency to let in different amounts of light. Depending on the weather, you can have the windows let in more light or less. Materials scientist Kwangmin Pei of Korea University explains.
So we need to develop the new design concept of the window systems which can efficiently tailor the lighting condition and temperatures.
Pei's team came up with an innovative design that differs from typical smart window approaches. Many popular designs involve making the window pane using a stretchy material. As you stretch the window, it opens pores in the material. These pores scatter incoming light, letting less of that light transmit through the window. Consequently, stretching the window pane lowers the transparency of the window. However, these designs require you to stretch the window pane a significant amount to achieve the desired decrease in transparency.
When we think about the window size about 1 meter across, this translates to stretching the materials more than 15 centimeter scales. And these severely limit the practical application.
Instead of creating a window pane you stretch lengthwise, Pei's team created a window pane that you compress in thickness. The window becomes more transparent when you compress it.
This kind of concept is very new concept of the smart window systems.
They found that they could reduce the transmitted light from 95% when compressed to as low as 6% when uncompressed. When uncompressed, the window turns a milky white color. They could consistently achieve this across the visible light spectrum, ranging from wavelengths of 400 nanometers in the violet range to 700 nanometers in the red range.
Its internal structures change, allowing the windows to switch from transparent to milky white.
Like other smart windows, this window also makes use of pores within the material to adjust its transparency. When you decompress the window, the pores open, which creates scatterers in the material to make it less transparent.
This kind of the pore efficiently scatter the incident light. So it is basically very milky white.
They made the smart window out of a polymer known as PDMS, which they placed between two panes of glass. To create the PDMS with the desired pore structure, they first create a sort of mold out of a material called NR. NR changes its properties when exposed to light. They beamed a laser onto the NR material to create 3D structural patterns of light-converted material within the bulk structure. This technique is called proximity field nanopatterning. This light-converted material can be easily washed away with ethanol to create the mold. After washing this material away with ethanol, they cast the void created with the PDMS. The resulting cast is the structured porous material that goes between the two panes of glass to create the smart window.
The final topology of the 3D PDMS scatter is literally inverse topology of the polymeric template.
They are now studying how they might customize the shape of the pores to tailor the transparency of the window.
We are now trying to do a research for which kind of the topology is optimized to create the maximum transmittance change under the specific strain.
This work was published in a recent issue of Nature Communications. My name is Sophia Chen from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org and follow us on X at MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thank you for listening.